Hey, hope you guys had a good weekend. Hope you're doing well. This is going to be the first video for triangle congruence proofs. Now, we're not actually going to get to many proofs today, but what I'm going to do is help you guys recognize what you need to put for certain givens, okay? Because the givens are going to kind of guide how your proof is used, okay? So we're not going to be doing full proofs today, just certain statements and reasons, all right? And kind of my vision for this, right, is this is kind of like a cheat sheet for you guys, like a study guide, okay? When you're doing your quiz or a take-home test or whatever, that you guys will maybe use this to help you do your proofs, or when you're doing your practice, okay? So let's go through. So the first given you could be given is midpoint, all right? So it says given D is the midpoint of AC. So if D is the midpoint of AC, what do we know, all right? Well, midpoint means the middle, right? If it's on the middle, both sides are the same. So what we know is that this is equal to that, all right? So if we were given that D is the midpoint of AC, we would follow that up by saying, okay, AD is congruent to DC, all right? And the reason would be midpoint, right? Or definition of midpoint. Let's just say definition of midpoint since I'm the teacher, but you guys can just write midpoint if you want. But that's kind of, for that given, what you would be able to write down. Okay, so if you're ever given anything about the midpoint, or if you kind of forget what you should do, come look at this. All right, this could help. Next thing is bisector, right? Remember, bisector means to cut in half. So if it says given BD bisects AC, guess what? That pretty much means the exact same thing as midpoint, okay? If it cuts it in half, this half is equal to this half. So we'll say AD is congruent to DC. And the reason would be definition of bisector. Okay. Next, we have angle bisector. Okay. So this one says BD bisects angle ABC. All right. So this one's a little bit different, right? It's an angle bisector, but it still means cut in half. Okay. So if it bisects ABC, that means this angle is the same as that angle. So these two angles are the same. So given an angle bisector, what we would say is we'd say angle ABD is congruent to angle CBD. And that would be definition of angle bisector. Now again, you could just say angle bisector if you wanted. So that's the first page. So those are three different givens that you could have, all right, and what kind of things you should write for them. Okay. The next thing that we're going to look at, all right, perpendicular lines. Okay, perpendicular lines. So you could be told that something is perpendicular. Okay. For example, here we're told BD is perpendicular to AC. So if it says BD is perpendicular to AC, what does perpendicular mean? Perpendicular means it makes right angles. Okay, so that means this is a right angle, and it means this is a right angle. So we know that angle ADB is 90 degrees, and we know angle CDB is 90 degrees. Okay? And that would be definition of perpendicular. Okay? And then if we know they're both 90 degrees, they have to be the same. Okay? So now we know that ADB is congruent to CDB. Now, what would our reason for that be? Well, think about it, okay? If they're both 90, right? If they both equal the same thing, then they are equal. That's actually the transitive property. Okay? So if we're given that the lines are perpendicular, that means that we end up knowing that those two angles right there are going to be the same, right? Remember, we need three things to prove triangles are congruent. So these are just different givens that give you a certain thing. Okay, sharing a side, all right? This one's not actually a given. This is something that you've got to recognize, but we talked about this last week. If two triangles are right up next to each other, all right, that means they share a side, right? That means that side is equal to itself. So we're going to say BD, that's the side they share, all right? BD is congruent to BD, and that would be the reflexive property. Okay, so that's something that I really hope that you guys will be able to recognize and that you need to. The next one is vertical angles. This is another one that's not actually a given, but just something that you need to see. All right, if you've got lines crossing and you've got the triangles where like their points touch, that means these two angles right here are going to be the same, right? Because vertical angles are congruent. So angle BEA is congruent to angle CED. And the reason for that would be vertical angles. Okay, so these last two ones, you guys definitely need to be able to recognize those two, reflexive property and vertical angles, all right? The last one is parallel lines. Parallel lines is a little bit hard, probably the hardest one, all right? It says BA is parallel to CD. So if you remember, this is what we put for parallel. So BA is parallel to CD. And what do we know from that? Well, I think it's easiest to see if we put some lines in here, all right? Because if you remember, if they're telling you that something is parallel, that means you're going to be using your angle pairs that are created by parallel lines, all right, in a transversal. So if we look at this, all right, we have our two parallel lines. We have our transversal CA that I just drew. And what gets created is alternate interior angles. All right, if you look, these two are alternate interior angles. So we know that BAC is congruent to DCA. And remember, that would be alternate interior angles. But those aren't the only alternate interior angles, right? There's actually two transversals here that it could be. It could be this transversal, all right? Which would mean we have a different pair of alternate interior angles. We have these right here. So you could pick either of the two. Maybe you need both, maybe you only need one. But for this one, we'd say angle ABD is congruent to angle CDB. And that'd also be alternate interior angles. So these are pretty much all the things that I could think of that you might be given. So like I said, this could be like a cheat sheet for you, all right? One of these are gonna be like how you start your proof, basically. You're gonna be given you could be given multiple of these things, okay? Because remember, you gotta get 3. But we're gonna look at an example, all right? So it says given, all right? E is the midpoint of BD and AC, okay? So remember, we always start with our given. So let's write that down. E is the midpoint of BD and AC. Now this one's a little bit weird because E is the midpoint of 2 different lines. So we're actually going to use the definition of midpoint twice, all right? So if we look, it says E is the midpoint of BD. So if we look at BD, all right, that means BE is congruent to ED, right? So that's going to be the first thing that we write down. BE is congruent to ED. That'd be definition of midpoint. The second thing that we've got, E is also the midpoint of AC. So we know that this segment is congruent to that segment. So that's AE is congruent to EC. And that's going to be the exact same thing, all right? Also definition of midpoint. And then, so that's already two things. So remember, we want to have three different things, okay? So this is so we've got one right here. We've got two. We need to figure out a third. Since we weren't given anything else, that means it's probably going to be something in our picture. Yes, okay, the lines are crossing. That means we have vertical angles right here, okay? So we could say angle DEC is congruent to angle BEA. And that would be vertical angles. And that's actually our third thing, right? So now we know that the triangles are congruent because we have three things, all right? Now, which three things do we have? Well, if we look, all right, let's try and write this down. We've got side. Let's do this. We've got side, angle, side, all right? Two sides and an angle with the angle in between the two sides. So we can say that triangle CDE is congruent to triangle ABE by side, angle, side. So that's why we spent so much time with those theorems, all right, so that you know what you need to put right here. All right, so for this one, it'd be side, angle, side. So this is how you do a proof. Basically, you prove that three of the parts are the same, then you figure out which three parts you have, then you say the triangles are the same. So go ahead and try your practice, right? Your practice is pretty short, just kind of doing these things, all right, that we just did. If you have any questions, let me know, and have a great day.